Enough of me blabbering on about analogs, even though I'll probably do some more blabbering. Let's be honest, I blabber a lot. Let's work through an example. Okie dokie. We have our analog input set up in our I/O manager. If we go into the sim, we can see when we click on it and move it around, it changes the voltage value, which ends up as a number at this address in the analog input file. So let's use this analog input to do something. Let's stick with the idea that the analog input is a temperature sensor. If this is a temperature sensor, what kind of machine or process might it be used in? How about this? We have a tank full of chocolate. It's being stirred by some kind of motor and mixing blade. The chocolate needs to be kept between a certain temperature so that it will mix properly. If it gets too cold, it will solidify. If it gets too hot, it will burn. Okay, so the tank has two sets of pipes wrapped around it, one that supplies cold water and one that supplies warm water or hot water. They both have actuating valves on them. When we want to heat up the tank a bit, we open the hot water valve while the cold water valve is closed. And if the chocolate gets too hot, we can shut off the hot water valve and open the cold water valve to cool the tank down. Over here, we have our temperature sensor. In other words, our analog input device. It connects to our PLC's analog input. Alright, we better throw some tags in now. First off, let's call our analog input here at 0.0 choc temp. That's the temperature of the chocolate, obviously. Now, let's go into the digital output file and create our two valve tags. The first output can be our cooling valve, so we'll call it cool. And the second output can be our heating valve, so let's call that one heat. Cool. Heat. You know what I mean. Alrighty. Now, should we put the mixer in? Yeah, why not? Let's make the third output mixer. Okie dokie. And something to control the mixer output? Go into the digital input file and let's make a start mix and a stop mix. But be careful, because if we have noticed, when we set up an analog input in the I/O manager, it takes the place of the digital input in the sim, so it can't be used anymore. This would not be the case in the real world. You would more likely have separate digital and analog input and output terminals, but in this simulator, they need to use the same space kind of thing. So for example, if we make this first input an analog input, as we have done here, then it is used up and we can't use it for a digital input. So if you go into the program and put a normally open function into your ladder logic somewhere addressed to I0.0, then it won't work because that is now an analog. If you want to use a digital, you'll have to use the next one. The next digital input available to us is I0.1. Okay, so we need to be aware of that. Okay, so we'll make our digital input I0.1 our start mix, and our input 0.2 our stop mix. And in the I/O manager, make sure you change these to push buttons as well. Okay, there we go. All right, I think I've covered everything in terms of tags. Yep. Good. So let's go and build the program. Firstly, let's throw in a hold-in rung for the mixer. Mixer output. Start mix to bring it on. Stop mix to turn it off. And mixer as usual to hold itself on. Easy. You've done that a million times now. Okay, now Apparently, the best temperature for mixing chocolate is between 60 and 70 degrees. So this means that if the temperature of the chocolate in the tank goes below 60 degrees, we want to bring on the heating valve. And if the temperature of the chocolate goes above 70 degrees, we want to bring on the cooling valve to cool it down a bit. Between 60 and 70 is the dead band. Nothing happens in there. Both valves are off. Okay, so how do we get the heating valve firstly to come on when the temperature is less than 60 degrees? Aha! Less than sounds like a compare function to me. So let's try putting in a less than function and let's fill in the numbers here that we'll need. Alrighty, now we know that we want to bring on the heat output when the choc temp, that's our analog input, goes below 60. Cool. And let's add another compare function to bring on the cooling valve. For this, we'll want to use a greater than. And we want to bring on the cool output when the choc temp goes above 70. Okay, now, what's wrong with the program? In particular, these numbers. I'll tell you what, you guys are pretty good at programming now. Let's take a break. And before the next lesson, I want you to write down what you think is wrong here. And we'll discuss our findings in the next lesson. Oh, and save your work, by the way. Cheers.